All right, so today we're going to add on to kind of the converter we've been using. So far, we've been looking at uh, one substance, like if I'm given how many atoms or formula units of that substance I have, kind of following the arrows to do the conversions to figure out what mass of that substance I have. Today, we're going to be looking at two different substances. We're kind of going back to what we looked at with balancing chemical equations, which I have one set up down underneath that. We're going to call that a straight line right there. So really, if I have two, uh, we kind of thought of this as two molecules of lithium fluoride reacting with one molecule of magnesium chloride, would yield or become, theoretically two molecules of lithium chloride and one molecule of magnesium fluoride. Another way to look at this is rather than having the numbers represent molecules or form the units of what I have, those are typically not molecules. Um, those could be considered, moles. If I have 2 moles of lithium fluoride and 1 mole of magnesium chloride, I end up with 2 moles lithium chloride, 1 mole magnesium fluoride. Let's say instead of that, I'm given 18 moles of lithium fluoride, and I want to know how many moles of magnesium chloride will I need. All right, so this is where kind of this new addition to what we've been doing will come into play. So first things first, kind of this moles X, moles Y. X is really whatever you're given. It doesn't matter if it's on the reactant side of the reaction or on the product side. Whatever it is I'm given, that's my X. So in this case, lithium fluoride, that's my X. Y is just whatever we're looking for. So in this case, if I'm looking for moles of magnesium chloride, that's my Y. So in this case, both X and Y are both on the reactant side. Um, so just like with all of that converting we doing, first step, write down what you know. I know 18 moles of lithium fluoride, okay? And get my conversion ready. So according to our new thing, moles of Y, or moles of what I'm looking for from the chemical equation, is going to go on top. If I'm looking for MgCl2, I come up to the chemical equation right here. No number in front of it, so it's implied it's a 1, so I'm going to put 1 mole of MgCl2 on top. And then on the bottom is going to be moles of X, or the moles of my starting material from the chemical equation. I started with lithium fluoride, come up here, 2. So 2 moles of lithium fluoride. So this is where our units and what it's units of becomes really, really important. So in this case, I can see I have moles of lithium fluoride here. It's implied this is over 1. So moles of lithium fluoride on top here, moles of lithium fluoride on the bottom. Those are going to cancel out, okay? So I'm left with moles of magnesium chloride, which is what my question's asking for. So in this case, I have 18, multiply by numbers on the top, divided by numbers on the bottom. 18 divided by 2, that should give me 9 moles of magnesium chloride. Pretty easy, pretty basic. Just remember, X is whatever you're looking for. Like we could have asked, if I scroll down a little bit here, if I produce 7.5 moles of magnesium fluoride, how many moles of magnesium chloride did I need? And we can kind of look at this one and, figure it out. But if I wanted to actually do it, okay, so in this case, let me do some erasing. So in this case, that's no longer my X. That's no longer my X. That's not my Y. That's not my Y. All right, so come back here. So in this case, we're given magnesium fluoride. That's my X, so that's right there. Magnesium chloride's my Y. So in this case, it doesn't matter. Once again, we're in the chemical equation. It is whatever we're given, that's our X. Whatever we're looking for, that's our Y. So write down what we know, 7.5 moles of magnesium fluoride. I take that times some conversion. Moles of Y or moles of what I'm looking for on top. I'm looking for MgCl2. That's over here. That's 1 mole of MgCl2. And then moles of X on the bottom, right? Yep, moles of X on the bottom. So MgF2, once again, that's 1. Really what I see here though, moles of MgF2 on top, moles of FGM2 on the bottom. The only unit I have left is moles of magnesium chloride. 7.5 times 1 divided by 1 is still 7.5 moles magnesium chloride. So then you might be wondering, if I come back up here, well, how do you go backwards? That's a very common question. I've been asked about this. The short answer is you don't. You never need to go backwards from moles of y to moles of x because y is always what you're looking for and x is always what you're given. So we'll never need to go backwards from here in any case. If we're working with one substance, we're really just working with the top. Um, so yeah, so that's it. That's kind of going from moles to moles from one substance to another. Hope that helps out. Good luck with the practice.